Hey guys, we're going to be looking at lesson 2.1 today. Chapter 2 is going to be all about beginning proof writing. So we're going to be making our way into writing proofs and taking a look at what are parts of a proof, talking about some truth statements, and then we're going to start going into actually writing the proofs and creating some two-column proofs. But for today, we're going to be looking at identifying parts of conditional and biconditional statements. So we have quite a bit of vocabulary in this one. Make sure you're writing these down. You're going to want these in your notebook. Our first one is a conditional statement. A conditional statement is symbolized by P and Q, so we typically use P and Q with this, and it is an if-then statement. So if something, then something else. And we denote that as P and then an arrow pointing at Q. So if P, then Q is how we read that. So a conditional statement is an if-then statement. If this condition, then this condition. The hypothesis. The hypothesis is the if or the P part of a conditional statement, or the P part of the biconditional statement. And you'll see what that is in just a second. So the hypothesis is the beginning part, so the if part. The conclusion is the then part, or the Q part of the conditional or biconditional statement. So the first part that you read is going to be your hypothesis. The second part is going to be your conclusion. Remember, you can pause these videos at any time to write this stuff down. Our biconditional statement. This is a conditional statement where P and Q must have the same truth value. When we talk about truth value, that means that it's a true statement or it's a false statement. So a biconditional is P if and only if Q. So they both have to have the same truth value. We should be able to say if P then Q, and also be able to say if Q then P, and both of those be true. And we'll kind of take a look at what that looks like in an example here in a second. So biconditional uses if and only if. The converse of a conditional or biconditional statement. This is the rearrangement of a conditional statement, so the hypothesis becomes the conclusion, and the conclusion becomes the hypothesis. So we're essentially taking the Q and putting the Q with the if part at the beginning, and taking the P and putting that with the then part. So converse is the rearrangement of a conditional statement so that the hypothesis becomes the conclusion and vice versa. And then lastly, a counterexample. A counterexample is an example that proves a conditional or biconditional statement is not true. So counterexample means you're finding an example that is proving that the statement is not true. Okay, we're going to look at some examples on identifying some of these parts. First is hypothesis and conclusion. So we're going to underline the hypothesis for each one of these and circle the conclusion. And then we are going to say, is it a conditional or biconditional statement? So let's look at this first one. Our hypothesis is the stuff that comes after the if. So if a population consists of 50% men, I'm going to underline the stuff with the if. So a population consists of 50% men would be our hypothesis. Then 50% of the population must be women. So our conclusion is the stuff after the then. So I'm going to circle all of the stuff after the then. So 50% of the population must be women is our conclusion. Now, we have to decide, is this conditional or biconditional? Well, I see if, I see then. I know those are part of conditional. For biconditional, I have to have if and only if. That is not here in this one, so this is a conditional statement. Conditional statement. All right, let's look at the next one. A polygon is a triangle if and only if it has 3 sides. All right. Hypothesis and conclusion. The hypothesis goes with the if. We don't have an if here. We have if and only if. We don't have an if then. So the first part of it is going to be our hypothesis. A polygon is a triangle. Is our hypothesis. The stuff after the if and only if is going to be our conclusion. Conclusion is it has 3 sides. Now we need to decide conditional or biconditional. I see that if and only if. That tells me right away that it's biconditional. Both of these have to be true. When you look at a biconditional statement, you might see this in another way. You might see this as a conditional statement and its converse. So if a polygon is a triangle, then it has 3 sides. If a polygon has 3 sides, then it is a triangle. Those two statements together would create a biconditional. It's saying both of these things are true, forwards and backwards. So it is a biconditional. I can truly put that if and only if in there. And then last one here. If we turn off the water, then the water will stop pouring. After the if is going to be our hypothesis. So we turn off the water as our hypothesis. And our conclusion is going to be after the then, the water will stop pouring. And we have an if and a then here, so this is again a conditional statement. Conditional statement here. Okay, hypothesis, conclusion, and deciding if something is conditional or biconditional. Next thing we're going to do is we're going to write the converse for each statement. I'm going to have to learn how to write small here. I didn't give myself a lot of room. So the converse again is we're going to take the conclusion, put it into the place of the hypothesis, and vice versa. So we already decided what was the hypothesis and the conclusion for this statement. The hypothesis is a population consists of 50% men. The conclusion was 50% of the population must be women. So we're going to switch that around. We're going to take the conclusion and write that as our hypothesis. So if 50% of the population is women, are women, I'm not sure which one to use there. Don't tell Mrs. Roskamp. If 50% of the population is women, so we turn, oh, we don't need a T on women. So we took our conclusion, we turned that into our hypothesis. Now we're going to write our then and put our hypothesis as our conclusion. So then a population consists of 50% men. Then we'll say the population. So we took the conclusion, made it the hypothesis, took the hypothesis and made it the conclusion. All right, now let's look at our biconditional here. A polygon is a triangle if and only if it has 3 sides. So again, we're going to switch this around. We're going to take the conclusion, write it as the hypothesis, and the hypothesis as the conclusion. So we're going to write a polygon has 3 sides. If and only if. And then we're going to take our hypothesis and move it to the end. It is a triangle. So a polygon has 3 sides if and only if it is a triangle. So again, taking our beginning, putting it at the end, taking our end and putting it at the beginning. All right, last one. If we turn off the water, then the water will stop pouring. We're going to turn these around. If the water stops pouring, then we turned off the water. So we took our hypothesis, put it as our conclusion, and conclusion we changed to our hypothesis. So if the water stops pouring, then we turned off the water. Okay, converse, switching things around, rearranging. Let's take a look lastly at counterexamples. So we're going to find a counterexample for the following conditional statements. So first one, if I'm a student, then I'm a male. So a counterexample here. Sally, some made up character here, but she is a high school student. Sally is a student, but not a male. So we're finding something that makes the first part true, but the second part false. So if we don't have the same truth value for a conditional statement, then we can prove that it's not a true statement. We're finding a counterexample, something that's proving it's not true. And then the second one, we'll throw a little math in here now. If 9 equals 2 times x squared plus 1, then x equals 2. Well, one thing we know about squaring a number is if we take a positive times a positive, it gives us a positive. But also, if we take a negative times a negative, it gives us a positive. So I know that x can also be negative 2. And I'm going to just kind of prove real quick that that's actually true. So I'm going to take this and I'm going to plug negative 2 in for x. So negative 2 squared is still 4. Negative 2 times negative 2 is positive 4. 2 times 4 is 8. 8 plus 1 is 9. So I found an example that makes this not true because x isn't 2, it's negative 2, and it still gave me a true hypothesis. So x equals negative 2 would be a counterexample, and the green part here is going to be our why. Why does that work? All right, now it's your turn to do some of this stuff. I have a statement, a conditional statement up here. If a polygon has 4 sides, then it is a pentagon. You need to write the hypothesis of the statement. So number 1 on your Google Doc, you're going to be writing the hypothesis. What is the hypothesis of this statement? 2, write the converse of the statement. So you're rearranging some things. Number 3, find a counterexample. And then number 4, tell me what the truth value of the statement is. Is this a true statement or is it false? And why? If you have any questions over this, please come see me. It is going to be important that we've got this vocabulary down well when we start proofreading. Have a good rest of your day.